What's up, everybody? It's Justin Alvey, Python Dev Warrior, back with another video. Welcome back, everybody. So in programming, we know that how we arrange data is very important. So that's why data structures and algorithms come up a lot and are used daily in a software engineering discipline. The data structure I'm going to talk about today is called the linked list, and a linked list uses something called a node. A node is a basic building block for data structures such as linked lists and trees. I want to mention that any node can have several different fields. One field is data, and another field is a pointer to a next node. So each node, they are lined up sequentially. So each node has a next variable that points to the next node in the sequence. On the screen is an example of the node class for building a linked list or a tree. As you can see, there are several common methods we can write to make using the node class easier. The initializer method is called with the input parameters self and initial data. An initializer method is also known as a constructor method, which is called whenever a class is first introduced. The main purpose of this method is to initialize the attributes for the class in question. In addition to this constructor, we can add getter and setter methods. As you might think, a getter method gets data for us, and a setter method allows us to set data for the given class. We have two of each, to set data and to add a new next node. So we can get the data at a certain node, and then we can also get the next node in that sequence. And we can do the same thing, so we can set that data, and we can set the next node in the list. Okay, now let's look at an example for nodes and linked lists. Okay, so I have this file here, main.py, and I have also next to it is the node.py that we already looked at. So we have the getter and setter methods for each node. So I created this main function. It's really simple. We added 3 new nodes. So basically it's just an empty function. And what you're going to see now is that I'm going to look at these nodes, I'm going to get the data, I'm going to set the data to make sure it all works correctly, and then I'm going to put them in a list. Okay, so let's get started. So for node A, we want to see we want to see element A, which is the first node, and has a value of 14. So a get data, get underscore data, boom, we're going to return that. So let's print that data. And as you'll see, we'll get 14, so that works correctly. We could try for the other ones. B, we get 17, which is correct. And then C, we should get 20, which is correct. Okay, so the one thing we haven't looked at yet, we've only looked at the data, so we haven't looked at the next node yet. So I can put all these elements, say I want to create a new empty list called nodes, and I'm going to append to that node, or that list of nodes, A. Copy that twice. And then I'm going to append B and C, and then we're going to print nodes. And you'll notice that we get 3 node objects, and it says it's some it looks funky if you look at it. Node.node object at this address, 0x0408. It's just some address in memory, and each one is at a different place. This is actually really important to notice because they're not continuous points in memory. So the addresses are all different. And you can also look at the get data for each element, and you'll see that the data is still correct, but this is just a regular list. This isn't a linked list. And we're going to see what a linked list and the differences are right now. A list or an array is comprised of data in contiguous memory. A linked list, on the other hand, is dynamic, and the data is not bound to one position. Okay, now that we've looked at nodes and creating a list of nodes, let's look at creating a linked list. So I've created this method here, create linked list from 3 nodes. Now it's highly specific because I know I'm only going to use 3 nodes. If we end up using more nodes, I'm going to have to change the list. But this is one way to create a linked list. Okay, so we have create linked list from 3 nodes. I'm going to pass in node A. I'm going to say node A. So the form I want to go for, I want to have A points to B, points to C, and C points to none. Because that's how linked lists work. The last element always points to none. So we're going to do A.set. I think it's set next. I'll have to check on that. B. Let's check. Yep, set next is B. And we're going to do the same thing. So B, set next is C. And then again, C dot set next is none. Now that's I think none is already specified as the next. Yeah, so self.next is always none if we haven't changed it, but I put it in here anyway. So let's comment out print nodes, and we're going to look at A, B, and C. Okay, so our code runs correctly. Now one way to let's return the first element. Oh, I see why. Okay, so our code worked. Creating a linked list from 3 nodes. Let's basically just call the function nodes A, B, and C. Now we're going to actually test it. Okay, it runs correctly. Let's say head equals create linked list from nodes. I'm going to copy this code up here so we know what we're looking at. And now we want to traverse that. So let's create another function, traverse linked. Actually, these should be underscores. So traverse linked list. That's a coding standard in Python. So create linked list. Let's insert all these. It's tedious, but it's important. From 3, I'm going to spell it out, 3 nodes. And now I've got to copy and paste this because we already copied it. All right, there we go. So let's just make sure the code still works. Yes, it does. No errors. Traverse linked list. So we're going to get the head as input. So what we want to do, we want to go through the linked list and print every value in that list. And then we're also going to one of the things that's really important in programming is figuring out what you want to do. So one of the restrictions I'm going to put on this code is that there's only traverse linked lists. There's only going to be 3 elements. And actually, we could, I changed that. I changed my mind. We're going to traverse the linked list no matter how long it is. So now we can do that by using a while loop. We'll say while temp variable is not equal to none, we're going to traverse through the list and print out every element. Now, one way we could do it is, actually, I think that's what we're going to do. So, yeah, sorry, I keep going back and forth on this. But we're going to traverse the linked list no matter the length. So temp equals head, while temp is not equal to none. Now, at first, we're going to give it the head variable, so it's going to be A, so it's not going to be none, so it's going to print the A value, then it's going to go to the B value, print the B value, then go to the C value, print the C value, but the next node after C is none, so we're not going to print that. So temp equals temp get next, temp dot get next. Okay, so we're going to print node value. We're going to do print temp dot get value, and let's see, print temp dot get value, and then we're going to format this. So this is just housekeeping. We're just going to look at each case. So format, boom. Yes. Okay. Alright, so let's give this a shot. We have head is the input, temp equals head, while temp is not equal to none. Print 0 dash dot format temp dot get value blam. Temp equals temp dot get next. Okay, so we're incrementing temp, but we're not incrementing it with numbers. We're incrementing it with the next node in the sequence. So let's see if this works. First, we have to call it traverse linked list head. Okay. Let's see what errors we get. Okay, so we got an error. Node head has no attribute get value. What line is that? Line 20. Get value. Oh, it's get data. There we go. Okay, so that was simple. That was an easy error to. Okay. So we get. All right, so we have our linked list printing out. We have 14, and that moves to 17, which moves to 20, and that's A, B, and C. Okay, so that's implementing a linked list in Python using a node. All right, that's it for this video. Make sure to like, subscribe, and I'll see you in the next one. Peace.